Hello, good morning. So here I am here to explain the five questions of my choice from the interview questions given in the Capstone project of module 5. So let's start with the questions. First question is, what is vector in mathematics? So in mathematics, vector is something which has both magnitude and direction. So let's say we have this vector. What happens is it has both magnitude and direction. The magnitude is equal to the square root of 7 square plus 7 square, which is the square root of the squares of sum of the squares of the individual components, and it is the length of the line is equal to the magnitude. If the magnitude is greater, the length of the line is greater, and the vector also has direction, which is the angle it makes with the x-axis. So this is the direction. We can get the direction using the tan value. So tan inverse of the tan value of tan inverse of tan theta will tan uh, mm, of the this right angle will give the angle of this. So let's see. What is vector is something which has both magnitude and direction, and the direction of the vector is from the tail towards its head. Vectors can be added and subtracted. These are the operations which we can do, and the resultant of the addition of subtraction of the vectors of two vectors can result into a new vector which can have new direction and different magnitude. So in science, what is the use of these vectors? So in the science and machine learning, the vectors are used for denoting various kinds of information like image, videos, audios, scientific simulations. So vectors can be n dimensional, like let's say one two dimensional vector which is a matrix which has both rows and columns, but it can have also 3 dimensional, 4 dimensional. So let's say we have an RGB image in which each pixel denotes a vector. So each pixel has three components like red, green and blue, RGB. So each point in each pixel in that image is a vector, and the collection and the image can be said to be a collection of vectors. So in this way we can do many mathematical operations on that image, like adding filters and many things which can lead which takes the image in the form of vector, and we can do many actions on it. So vector simplifies the way we interpret data in statistics, machine learning and mathematics. So how is a vector different from a scalar? This is the second question. So a scalar has only one magnitude, but vector has both magnitude and direction. So scalar can be only one dimensional, but vector can be n dimensional. Like I said, matrix is a 2 dimensional vector. It can be of n dimensions. It can be of 3, 4, 5, any dimensions. So the operation of two scalar like addition or subtraction gives rise to another scalar, but the operations on vectors like dot product and cross product can give scalar value or vector value. So dot product will give two vectors a and b will give the scalar value of magnitude of a into magnitude of b into cos theta, and the cross product of the which is of the two vectors will give another vector which is a vector which is perpendicular to both the vectors. So that way different operations in non-vectors give rise to different values which can be scalar or vector. Let's say example of scalars are the various quantifiable measurements that we are doing in physics, maths and other sciences. So but it are those are the values which do not denote any direction, like length, mass, weight, energy, density. Length doesn't have any direction, and so does the other things. So like, but in vectors, these are those quantifiable values which have both direction and magnitude. Like force can be applied in a particular direction with a specific magnitude. Velocity is the traveling of something towards a certain direction, and the speed which it attains is the velocity. Acceleration is also the differentiation of velocity. So these all have direction, so they are vectors. Now let's move to some probability questions. So what are the primary components of probability theory? So probability theory is something which is concerned with the analysis of random events, and there are multiple components in the probability theory. First is the sample space. It is a set of all possible outcomes of an experiment. So let's say we have a dice. We have we want to throw a dice, and we want to it can have certain possible values. It can have 6 values from 1 to 6, and all these values comprise of the sample space. This is the sample space of one throw of dice. But what is a event? Event is the subset of the sample space that we are interested in. Let's say our event is odd even numbers. So it is the so the events will be 2, 4 and 6. These are our events. So next is probability. Probability is the likelihood of the occurrence of an event. So the number of events we have is 3. The number of events we have is 3, and the total number of elements in the sample space is 6. So this is the formula for probability. It is the occurrence of the probability of occurrence of even is equal to, we can say, 1 by 2. This is how we get the probability. So next is probability distribution. It is the likelihood of each possible outcome of a random variable. So let's say our variable is the of the value of the values that the dice can give when we are throwing a dice. So each possible outcome is the the likelihood of each possible outcome is the probability of attaining each value, like one probability of attaining 1, 2, 3, 4, all of them. And this when they are totally taken into account, they give rise to a probability distribution. And the random variable is a variable that can take different values with certain probabilities. Probability function, it is the assigned probability to each possible value of a random variable. So as I said, if we plot the values of the dice on the x-axis and the probability of that value on the y-axis, it gives rise to a line graph, which can be said to be a probability function, because it consists of each of the probability of each random event in the sample space. So in the rules of probability, are addition, multiplication rule, complement rule, that which govern how probabilities combine and interact. Probability models. So what are probability models? Probability models are the simulation of the real world events. It is taking into account all variables and their probabilities, and creating a model which can which can give us statistics on which we can base our assumptions on that sample space. So these are the components of the probability theory. Next is, what is conditional probability? So conditional probability is the probability of occurrence of one event given that another event has occurred. Let's say our event A equal to event A is occurring of even when we throw a dice. So what are the how many events are there? So even is 2, 4 and 6. And let's say we have another event which is equal to the probability of a value greater than 4. So what are the values in that event? Are 4 greater than 4 are 5 and 6. So the number of even is 3, and the number of having greater than 4 is 2. So probability of B given the occurrence of A, that is the probability of having a value greater than 4 given the we have an even outcome. So what will be that? That is equal to probability of B intersection A by probability of A. So what is the probability of B intersection A? It is the probability of what is the what is the intersection of B and A? It is the value greater than 4 and even. So how many values are there which are greater than 4 and even we have only I think one value, which is 6. So the probability number of events is 1, and the total probability and the total number of samples is 1 by 6. So the probability of B intersection is 1 by 6, and the probability of A is 3 by 6. So what is the probability of the conditional probability of B by A? It is equal to 1 by 3. So that is how conditional probability works, and that is the formula for conditional probability. So I have completed 4 of them. Let's say we do another one. So what is the law of large numbers and how does it relate to probability theory? The law of large numbers states that the number of trials of the observation of a random event increases. As the number of trials of the observation of a random experiment increases, the sample mean approaches the population mean. So what is the sample mean? It is a mean of the sample, means the experiment we are doing, all the trials in the experiment is the sample. And what is the population? It is the theoretical mean. It is the expected value, means it is the average value of all the elements in the sample of the population. So according to the law of large numbers, let's say we are doing a fair throw of coin toss. So what is the probability of head is equal to 1 by 2, because there is only one outcome favorable, which is 1 head, and there are two outcomes, head and tail. So what this law of large number states that, so let's say we are throwing a large number of, we are doing a large number of trials in which we are throwing dice one by one. So what happens is, even if we take like 5 dices, let's say we are taking 5 dices and we keep throwing them, so the expected value, which is the 5 into 1 by 2, which is 2.5, it will be in the middle. So it will, the probability, the number of if we do the mean of the all the outcomes in the sample, we find that it will approach towards this 0.5, and this happens only when we are doing a large number of trials to understand how it works. So both the law of large numbers and central limit theorem are interconnected. So large number states that the sample mean moves towards the expected value, which is the theoretical mean. But in large numbers, what happens in law of in central limit theorem, what happens is that we see that this mean, if we take the average of all the outcomes, it will give us a uniform distribution. So since all the means, most of the means are towards the center, which is the towards the mean, the theoretical mean, so the number of elements in the middle of this will be greater, and as we go towards the other sides, both sides, the amount, the number of the likelihood of that number occurring will decrease. So this happens because of both central limit theorem and law of large numbers. So but to understand the proper uniformity of this graph, we have to do a large number of trials, otherwise the graph may look like this, it may not be properly uniform, or it may look like this, and it may not be properly uniform. To understand it proper uniformity, we have to do a large number of trials, and that is what the law of large numbers and central limit theorem are defining. So these two theorems are very important in the probability theory, because they govern the principles of expected value and other things. So these are my 5 questions that I had to explain. Thank you very much. Bye.